Okay, so picture this. You're late, you're sprinting through a massive lobby, you jab that button, and those metal doors just slide open. You step inside this little box, and then, whoosh, you're just flying hundreds of feet straight up in seconds. There's no engine roar, no wings. So what is going on? Well, it's not magic. It's an incredible hidden world of engineering. And today, we are going on a mission to uncover the insane machinery that makes elevators the safest rides on Earth.
All right, mission accepted. We are going behind the walls right now to reveal the secret mechanical heart that powers our entire vertical world. First things first, we got to identify our main targets.
So you've got two main players in the elevator game. For shorter buildings, say under 5 or 6 stories, you have hydraulic elevators. They work kind of like a giant car jack, using a piston to push the car up. But for the real skyscrapers, you need the heavyweight champion, the traction elevator. And that's exactly what we're investigating today. Okay, first look behind the curtain. This is the whole setup. Way up at the top, you've got a big electric motor, and it's turning that grooved wheel, which is called a sheave. You've got these super strong steel ropes looped over it, connecting the elevator car on one side to its mysterious partner on the other, the counterweight.
And here it is, the unsung hero of the entire system. The counterweight is the secret sauce, the absolute genius behind the elevator. It's basically a stack of weights that's as heavy as the elevator car is when it's about half full.
Seriously, just think of it like a perfectly balanced seesaw at the playground. As the car goes up, the counterweight goes down. Because they're balanced, the motor doesn't have to deadlift thousands of pounds. It just has to nudge the difference in weight. It's such a simple physics trick, but it saves a mind-blowing amount of energy.
Okay, next part of our mission, we're looking into the one thing everybody secretly worries about, those steel cables. Or, as we like to call them, super strong steel spaghetti.
So here's the deal. An elevator isn't just hanging by a single thread. No way. It is held up by a whole bunch of hoist ropes, usually somewhere between 6 and 8 of them. And get this, each one of those ropes is actually made of tons of smaller steel wires, all twisted together for incredible strength.
And you have got to hear this, because this is the knockout fact that destroys every action movie you've ever seen. Are you ready? One single cable is strong enough to hold the entire weight of the car and everyone inside it. All the others, they're just backups, redundancy. The chances of all of them snapping at once is, it's practically zero. But, what if? What if the impossible somehow happened? Well, the engineers who designed these things were brilliantly paranoid. They built in these secret guardians, these mechanical superheroes just waiting for the one moment they're needed to spring into action.
Yeah, exactly. Let's say something makes the car start going down way too fast. We're not even talking about cable snapping, just what stops it from free-falling. This, my friends, is where the real magic happens. Say hello to the elevator's silent protector, the overspeed governor. It's this special wheel up at the top of the elevator shaft, and it has its own separate cable that's attached to the car. And its only job is to watch. It's constantly monitoring the car's speed, just waiting. And if that car starts to speed, centrifugal force takes over. These weighted arms inside the governor start spinning so fast that they fly outwards, and they trip a switch. That switch yanks on a totally separate brake cable, which, bam, triggers the emergency brakes on the car itself. It's a purely mechanical chain reaction. It doesn't even need electricity to work.
And this is the grand finale. That brake cable activates the safety gear. We're talking about a set of massive, powerful brake wedges right under the car. These wedges slam into the steel guide rails on the side of the shaft and bring the car to a screeching, secure halt. It doesn't drop, it just stops. That is some genius-level safety right there. Oh, and we're not even done. There are layers upon layers of safety. The main motor itself has this big electromechanical brake that automatically clamps shut if the power goes out. The doors have interlocks, so there's no way they can open between floors. And at the very, very bottom of the shaft, there are these giant buffers, basically huge shock absorbers for the absolute worst-case scenario. This thing is over-engineered to be unbelievably safe. Okay, we've confirmed the target is secure. Now for the final phase of our mission, looking at the future. Because elevators aren't just getting safer, they are getting a whole lot smarter. So check this out. It's called regenerative braking. When you have a heavy, fully loaded elevator car going down, The motor has to act like a brake to control its speed, right? Well, modern systems can actually capture all that energy from the downward trip and turn it back into electricity that the building can use. How cool is that? It's literally making power. And this is where things get straight up science fiction. What if you just got rid of the ropes completely? Well, meet the MULTI elevator system. It's a prototype that uses magnetic levitation, maglev, to move elevator cars around. So instead of ropes, the shafts are lined with magnetic coils that literally pull the cabins up or control their descent. And look at this. These incredible rotating track sections let the cars switch from going up and down to going side to side. It's like a train system inside of a skyscraper, with multiple cars moving around in a constant loop. Wild. So the next time you step into an elevator and you hear those doors slide shut, just take a second. You're not just in a metal box. You are riding inside a masterpiece of engineering, protected by over a century of clever physics and so many redundant safety systems that quite literally will not let you down.